So now let's start with when you were in kindergarten, you were asked to go 3 apples plus 4 apples equals what? You probably are wondering why we're spending so much time on kindergarten stuff, but that actually forms the basis of higher level mathematics. So let's start with 3 apples. The way we do counting number addition is you take the 3 apples and you count 4 up from 3 apples. So we have 3 apples, 4 apples, 5 apples, 6 apples, 7 apples. That's my 4th apple added. So when you add 4 apples to 3 apples, you end up with 7 apples. You just counted 4 up from 3. That's how you learn how to add when you are in kindergarten or 1st grade. So the answer to 3 apples plus 4 apples is 7 apples. What if I ask you to do the reverse question? What if I ask you what's 4 apples plus 3 apples? What would your answer be? Pause and think before you answer. So you're going to start with 4 apples and count 3 up from 4. So 5, 6, and the 3rd apple will give me 7. So clearly you get 7 apples even if you do 4 apples plus 3 apples. And you might be saying to yourself, that's a no-brainer. That's nothing really to this. But actually it's a very important observation that we have here. That 4 apples plus 3 apples is 7 apples. 3 apples plus 4 apples is also 7 apples. So another way to see this problem would be we have 3 apples here, 4 apples here for a total of 7 apples. But if you started with 4 apples and then added 3 more apples, it's still 7 apples. This property where the order in which you added did not matter is called the commutative property of addition. In mathematics, several objects satisfy property where if you add one plus another and reverse the order of addition, you still get the same answer. That's called the commutative property of addition. These words are going to be important for you to memorize because later on when we ask you to justify a statement, justify your logic or your thinking process on a problem, you should be able to say, I have this answer because I was using commutative property of addition. So you should be familiar with it. So this property works not just for numbers, but right now we're saying if A and B are any two mathematical objects that you've studied so far in Module 1, then A plus B is equal to B plus A. Or the summands can change order and the resulting addition does not change. And the terminology we want you to keep in mind is what? Addition is commutative. Just remember that word. Remember, we use the word commute in daily life, going back and forth. So you can add A and B back and forth and get the same answer. All right, let's see the word associative property. Associative, we use the word associate all the time also. Anyway, let's take a look at 3 apples plus 2 apples. So that'll give me 5 apples. And if I add 4 more apples to it, then I'll end up with 9 apples. You can count, right? 3, 4, 5, and then 6, 7, 8, 9. So that's 9 apples. I'm adding the 3 and the 2 apples first, and then whatever that result is, adding 4 apples to it to get 9 apples. What if I do the following? If I add 3 apples to the result of the addition of 2 and 4 apples, so 2 apples and 4 apples will give me 6 apples, and then 3 apples plus 6 apples will give me 9 apples. So in other words, it did not matter what order you added them in. You could add 3 and 2 first, and then add the 4 to it, or you can add 3 to the addition of 2 and 4. This can be true with all the mathematical objects you've studied so far. So if A, B, and C represent any 3 mathematical objects we've studied so far, then if you add A plus B plus C, where you're adding the A and the B first and then the C, or you can add A to the result of the addition of B and C, the answer is going to be the same. This is called the associative property of addition. So addition is associative. That's another way to say that. In other words, you can change the summands and the sum is not affected. And if you combine it with the previous property, which was what? Do you remember the name? Good. commutative property of addition. If you combine associative property and commutative property, which means you can interchange the order in which you add them, or does not matter which two you add first, it will give us what? That you can add objects in any order they appear as long as you add all of them. So I can add A and C first and then B to it, or I can add B and C first and then A to it. It does not matter as long as you add them all. Something to keep in mind. All right, let's take a look at additive identity. Well, let's just consider 0 apples and see how they interact with the 4 apples. If you add 0 apples to the existing collection of 4 apples, or if you add 4 apples to 0 apples, you end up with 4 apples, which means that if you add a 0 to any number or any mathematical object for that matter, then what happens? The quantity does not change. So in general, additive identity, in this particular case, our additive identity is 0, is the following. If we let A be any mathematical object, and we add the number so that the result is the same, nothing changed, then that number is called additive identity. In our case, it's 0, because A plus 0 is A, and 0 plus A is also A. So 0 is going to be additive identity for us. Just keep that in mind. All right, let's take a look at addition of counting numbers in general then. If you're working with counting numbers like we did 3 plus 4, then you counted 4 up from 3. What if you have 26 apples plus 59 apples? That means you're going to have to count 59 up from 26. Like 27, 28, 29, 30, 31, 32. Wait a minute, I'm not going to be counting 59 up from 26. That's not very practical, is it? So to add numbers in our decimal systems, because you're a mathematician, you have to find an easier way. You're not going to sit there counting 59 up from 26. So what do? What we do is we line up our decimals so that each place value is lined up. This allows us to add like units, the unit being the place value. And then we only have to add numbers 0 through 9. So let's see how that works. So we can visualize the 26 apples and the 59 apples the following way. We have 26 apples can be thought of as having 2 boxes of 10 apples and 6 loose apples. And 59 apples can be thought of as 5 boxes of 10 apples and 9 loose apples. So if you have 10 apples, they form a box. And if you have loose apples, then you can combine them. So if you have 9 loose apples and 6, I can take 1 apple from this 6, add this to the 9, and make 1 whole box. And so now there are 5 more apples left. So we have 5 single loose apples left. And here we have 8 boxes. So lining up the decimal place values allows us to add. So again, let's do it a little bit differently. Instead of apples and boxes, let's just do number of digits. Line up the decimal point. Line up all the digits. If digits are missing, just place zeros in their places. And then add. So 6 singletons here, which means that this is in the hundredths place. 6 hundredths and 6 hundredths will give you 12 hundredths. But we've seen that 10 100ths make it a tenth. So one of them can go into this column, just like we were doing with the boxes. So 2 stays here. The 1 carry over because 10 100ths made 1 group of tenths. Okay, add those. We got 10, and 10 tenths make 1 singleton. So it will go 1 there, and there are 0 loose objects left. Then add here, we get 17. Do the same thing, carry over the 1 because 17 singletons is 7 singles and 1 group of 10. Add here, we get 16 tens. So you have 6 singletons and then 1 group of hundreds, and then total 9 hundredths. So line up all the digits. If there are missing place values, put 0 in their places, and then add in each column across. If there is 10 of something, they go to the next higher place value, and then you just add in that manner as many digits as there are. So that's how the standard decimal addition algorithm works. It's important to understand this decimal algorithm because it forms the basis of all the other additions. All right, so here's a video log questions that we would like you to think about.